Welcome back with another video on TryHackMe.com. This is Zaheen Nazir and we are doing on-premises IaC, which is part of the infrastructure as a code module, which is part of the DevSecOps learning path on TryHackMe.com. So we have already done from task 1 to task 4. So in this video, we're gonna do the task 5 and task 6. And video after that, we're gonna do this 7 and 8. So as you can see on the right hand side, I already started my attack box, and I also started the target machine in the task 5 as well. So let's get into it. Providing an on-premises IaC workflow, creating an IaC pipeline. Okay, now that we have learned the basics about on-premises IaC, it is time to put our knowledge to the test. Start the machine, attach this task by pressing the green start machine button. This machine will start in split view. In case it's not showing, you can press the blue button which is on top of the page button to at the top right of the page. Okay, once the machine has started, you can navigate to the home Ubuntu IaC directory. Okay, so let's do that. Get a home. I don't see any Ubuntu here. Yeah, it's already in the Ubuntu. So I'll go into the IaC. So if you go to the path itself, how can I copy the path? See, if you click on the pencil icon, you will see the whole path here, as you can see here. We are okay with that. Okay. All of the scripts that we will be using today can be found in this directory, vagrant file. Let's start by taking a look at the vagrant file. Okay. So this is the vagrant file itself. I don't know what they are using to open it, but I will just open it anyway with Pluma. Okay, so it gives you, the file without any kind of color coding, but we can see on the left side there is a color coding thing. I don't know what they are using here, but okay, let's try to read it from here on the left side. Vagrant.config, this is 2, and the vagrant file itself, in which language it is written. I think it's written in the Ruby. We will do then the config. DB server will be the backend for our website, so we'll create the DB server first. Config.vm.define. The name is DB server. Do CFG, just so now we are configuring the network itself. Configure the local network for the server. cfg.vm.network, private network, and type is DHCP. That means we're not gonna give any IP address to it. Then we have docker underscore network underscore internal is equal to true. cfg.vm.network, private network, and the IP address is this one. The net mask is 24. Okay. Boot the docker container and run the ansible. cfg.vm.provider is docker. So docker is kind of the integration between the vagrant and the docker itself. So we'll provide everything in a docker Ruby syntax, and we'll just provide which provider will be targeting on. In this case, we are targeting docker, so it will basically call the underlying API and do all these things for us. Okay, but we are required to just mention what we need to do here in the vagrant file. Okay, so there is a D. D is the config, the object itself. D.image, then MySQL image will take, then the environment is MySQL root password, which will come from my secret password. This is a bad practice, by the way. This should not be the case. The password itself should come from a variable, right? Environment variable or some secure environment variable or something like that. We already covered this one in our previous videos. I think in the pipeline section, just check it out in the playlist that I have put forward on the YouTube. Web server will be used to host our website. Config.vm.define web server, do CFG. Okay, so we are defining the web server now. Config the local network. Still it is a DHCP, and this time we are mentioning 2 instead of 3, as you could see here. But the network itself is the same, right? So that when they can communicate with each other. Link the share folder with the hypervisor to allow data pass through. Sync folder is this one, .provision, and then the temp dash provision. I will go into the container itself, I think Docker itself. Boot the Docker container and run the Ansible. We are booting up the Docker, and the image is Ansible 2. Then has ssh is equal to true. Then the command line is user sbin sshd. I don't know what does that mean, but it is saying the command will keep the container active. Okay. We will connect using SSH. So override the defaults here. I will use the root user here, and then the private key path is over here. Home Ubuntu IaC keys id underscore RSA. Provision this machine using the Ansible cfg.vm.provision. We will be using the shell, and we have the script that will be running on this shell. It is Ansible playbook temp provision web playbook.yaml, and then we are here at the end. This is quite a lot, that you need to do. I hope there is a drag and drop kind of user interface where you can just define what you need through a diagram, and all of this information can be generated based on your diagram. Okay, that would be very nice, very cool. Okay, in this background file, we can see that two machines will be provisioned. We know that first one is DB and the second one is the web server here. All right, let's move on. DB server. The first machine that will be provisioned is the DB server working through the lines of code. We can see the machine will be added to a local network and receive the IP of this 172.21.28.3. We can also see that the provision directory will be mounted as a share. Lastly, using Docker as the provider, this MySQL image will be booted, and the MySQL password will be configured to be my secret password here. Web server. The second machine that will be provisioned is the web server, similar to the DB server machine. It will be connected to the network and use Docker as its provider. However, there are some slight differences. Firstly, the web server will expose SSH. Yes, since we are using Docker, we have to alter some of the default vagrant configuration to allow vagrant to connect via SSH. This includes changing the username and the private key that will be used for the connection. Secondly, we can see that an Ansible playbook will be executed on the container by looking at the following one. Yeah, we already seen and explained this. Let's take a look and see what this Ansible playbook will do. Okay, Ansible playbook. Let's start by reviewing the web-playbook.yaml file. Okay. So it should be under provision. This is the file we need to see. So I will open it in Pluma here again. So we can see, look, host is localhost and connection is all, and roles are web app here. This is a simple Ansible script that indicates that the web app role will be provisioned on the host. To better understand what the web app role will entail, we can start by reviewing this one. IaC provision roles, web app task, and main.yaml. So include task, db-setup.yaml, and include task is app-setup.yaml. So we can see that, by the way. So these are the roles. We have web app. Then we need to go to the tasks, and then we have db setup and app setup, and then we have main itself. So now we don't want to run it. We just want to open it. Display. Okay. So this is the same as they are showing it here. Let's move forward. This shows us that there will be two main portions to the Ansible provisioning at this point. It is worth taking a look at as well at the default values in the here, which is web app defaults main.yaml file. DB name is bucketless, user is root, password is my secret password, DB host is this one, and API key is a super API key. Wow, so everything is there inside the YAML itself. So this is a bad practice. We'll get back to these variables in a bit, but keep them in mind. Sure. DB setup. We take a look at the dbsetup.yaml file. All right. Let's open it. Oh, there's a lot of things. I think as compared to this one on the right, left is more suitable for us, I think. Name, create the temp folder for SQL scripts. Ansible is built-in file. Then we have path, which is going from temp to SQL. State is directory. Name is time delay to allow SQL Server to boot up. Shell sleep 10 seconds, I think. Now name is copydb. Creation script with the injected variable. Template is template create db.sql. And source is this one, and destination is this one. Temp SQL create db.sql. Then you do another copydb sp script with injected variables. Okay, this is store procedures we are creating, and then the name is create db. We are creating the db itself. Then mysql-user. So db user will come from the file that we were seeing before, which is this one. This is the variable that we are putting here. Then p is the password here, then h is the db host here. So db host is this IP address, and then the script to create the db is here. SQL create db.sql. Okay, create store procedures, shell whatever we are creating store procedure as well, and then at the end we are cleanup scripts. Shell remove.or, we are removing the directory and all its components. Yeah, awesome. A lot of theory. I don't know if we need to do all of this as soon as they are explaining it here, or we should wait and do it later on. I don't know. Oh, okay, let's see. At least we cover the theory itself. From the script, we can see that 7 tasks will be performed. Reading through these tasks, we can see that a temporary folder will be created where SQL scripts will be pushed to and then executed against the database host. Let's take a look at how Ansible would inject these variables from before. Take a look at the createDB task shell command here. So we have shell MySQL. We have already seen this one before. As you can see that 3 variables, db user, db password, and db host will be injected using either the values of the default file or our return values if they exist. Okay, Ansible allows us to take this step further. Let's take a look at the actual createdb.sql file. So we are dropping the existing db, which is very dangerous. So if you have any data and you are running the script, that means the existing data along with db itself will be deleted. So always take care of this script line here. CreateDB will be creating the DB itself, then we'll be using the DB that this is the current DB we'll be pointing to. Then drop table if exists, table underscore user. Okay, and then we are creating the table itself with the table user, user ID, which is big, and auto increment. I think it is a primary key as well. Username, user underscore name, and user name, and then password, and then the primary key is user ID. Yes, yeah. All right. As we can see, these variables are even injected into the file template that will be used. This allows us to control the variables that will be used from a single centralized location. When we change the user or the password that will be used to connect to the database, we can change this in the single file location, and it will propagate throughout all provisioning steps for the role. This is very, very awesome. Now we have web setup. Lastly, we'll take a look at the app-setup.yaml file. Name is copy web application files, and shell is we are copying something from vagrant, provision, roles, web app, template, and app. Excuse me. To the root of the directory on the container, and then we are copying Flask app script with the injected variable template, and then the source templates app.py, and destination is app folder and then app.py. Awesome. So this file only has two tasks. The first copies the artifact required for the web application, and the second copies the web application file as a template. A template copy is performed to ensure that the variables such as database connection strings are injected into the script as well. We will not do a deep dive into the rest of these files that will be used for provisioning. However, it is recommended that you can take a look at these files to gain a better understanding on how exactly we are provisioning. Awesome. Running the IaC pipeline. Now that we have an understanding of our pipeline, it is time to start it. Let's start our pipeline and the provisioning using vagrant up from the IaC directory. Okay, so I will close all these files. So we need to go here. All right, so I will open a terminal from here. So we are already there in the directory. So they're saying that just do one thing, vagrant up. Well, you may see some red. Okay, so we'll just run the vagrant up because there is already vagrant file, so it will take care of it. Okay, the pipeline will take a while to boot, but pay attention to what is happening. While you may see some red or terminal on the terminal when the Ansible provisioning step is running, as long as these lines only indicate warnings, not an error, the provisioning will complete as expected. Yeah, these are warnings, not the error, so everything is in green. We are good to go, I think. Once our pipeline has provision the machine, we can verify that they are running using the Docker PS. Okay, so it's still running, so we'll wait it. Once it is done, then Docker PS will run. Okay. Warning. I don't know if this is the error or... Yeah, most of them are warning, as you can see here. Warning. All right, it is done. So let's run Docker PS. We should have at least two containers. So we have Docker entry point and IaC web server, which is here, and there is an IaC DB server here as well. All right, so we are good. If this is running, we can start our web application using the following command: vagrant docker exec it web server python. Okay, so we can, I think I will copy this command just to be sure and save the time. Right, I'll press enter here. So docker exec it will basically execute some commands in an interactive mode on the web server container, and it does so. Okay, and it is running the application, and it will keep on running unless we press Ctrl+C to quit it. Okay, so let's load our application. Once loaded, you can navigate to the web application, which is this one here. Copy, and let me open a Firefox here. Congratulations, you have executed a very first IaC pipeline. Okay, let us verify first. Then you can congratulate us. All right. Amazing guys. We are learning new technologies, new tools. It is taking a lot of time for Firefox to open. I don't know why it is taking long, guys. Okay, so I will just copy paste here, paste and go. All right, awesome. What is the flag display on the web application that is hosted? I don't see any flag here. that is hosted after your IaC pipeline provisioning. You will need to create a profile and authenticate to view it. Okay, so let me sign up for it. So my name is Zahir. My email address is Zahir at TryHackMe.com. Password is nevertheless super secret password, and then sign up. Not now. Okay, so I am successfully signed up. So let me log in. This is my password, so I'm gonna sign in. Hopefully I will be able to get the yes. We have the flag here. Awesome. Copy and paste here. Awesome. So let's continue. And this task I think is not related to the machine itself, so I'm gonna minimize it. All right, so let's continue with the theory itself. Okay, security concern in the on-premises IaC. When using IaC, regardless of whether the deployment is on-premises or on cloud-based, there are several things to consider for security. If you are looking for security best practices, cheat sheets such as these from OWS, cheatsheet.ows. Let's see that what we have here. It would be interesting. Deploy, runtime references, and a lot of other things here as well if you want to see, right? And this is for infrastructure as a code, cheat sheet, plugins, threat modeling, managing secret, version control. Yeah, we highlighted the managing secrets here. Okay. Are a good place to start. Even frameworks such as NIST. Now NIST have 2.0. Before I think 1 or 2 months it was still I think 1 point something from the NIST. Now they have 2.0 as per the news that I heard. I haven't looked at it. Maybe there is a room for NIST 2.0. We'll cover that one as well on this channel. All right. Provide information on how to secure IaC. However, in this room, we will focus more on practical security of the IaC, common mistakes that are seen in the real world. This is not a comprehensive list of things to take into consideration, but it is a great start, either protecting your IaC pipeline against real-world attacks, or what to look for if you are attacking an IaC pipeline or on a red team engagement. In total, these are 4 main elements to consider. Okay, the first one is dependency. We have covered dependency quite a lot on this learning path, DevSecOps. You can check it out, I think, in the dependency management room that is there also on the playlist on my YouTube channel. All right. The first element of IaC pipelines where security has to be considered in the dependencies. Similar to a software pipeline, our IaC pipeline will have dependencies. In IaC pipelines, the biggest dependencies are the base images that are pulled and used to build the infrastructure. If these dependencies have any security issues, these issues will propagate through the pipeline. All right. So they have mentioned a pipeline kind of setting here in the context of chemistry. A common example would be a vulnerability in the OS version of the image. If the image itself is not updated, the deployed hosts would have this vulnerability. As such, it is important to ensure adequate dependency management for resources used in the IaC pipeline. And anytime you are making use of third-party software or systems, it can introduce a dependency risk. For more information on dependency management and the potential vulnerabilities, have a look at the dependency management rooms. Yeah, so we already covered this one before. You can just look at in the playlist in the YouTube channel. Okay, I will also put a card over here or over there. A common security flaw in IaC pipeline is not altering defaults when host and services are initially provisioned through an IaC pipeline. It is extremely common for these systems to be provisioned using default credentials or connection strings. Ultimately, this is intended as these default credentials are used by the tools in the pipeline to provision the hosts. The security misconfiguration is therefore not the default credential, but not removing or altering them as the final step in the IaC deployment. This is very true. For example of the default credential in the credentials used by the vagrant to provision Windows host, Windows images provisioned by the vagrant often have a built-in default account of vagrant that has a password of vagrant as well. This is to allow the vagrant script running on the hypervisor to connect to the host for file transfer and script execution. If at the end of the deployment this default user is not removed, a threat actor could use this to connect to and take full control of all hosts deployed through the IaC pipeline. Yeah, that is true. Another issue with defaults is in the services deployed on the host. Let's say, for instance, that our IaC pipeline is used to deploy a CI/CD pipeline and would therefore install the Jenkins role on one of the hosts. It would be common for this role to be installed with default credentials of Jenkins, which would be Jenkins. In this case, we cannot really alter these credentials in the last stages of the IaC deployment, but expect the software engineers that will use the CI/CD infrastructure to alter the credentials. That is true. In some cases, this is not performed, which then leads to insecure infrastructure in the deployment because of the configuration. In other cases, even if the software would require the user to change their password with the first login event, as the software is never used, the default credential remains. Nobody is trying to log in, so default credential will be still there, allowing a threat actor to compromise the service and potentially its underlying infrastructure. As such, when building an IaC pipeline, it is important to make note of the cases where defaults are used and where they may be risk if not altered. The alteration of these defaults should then either be embedded as the final steps in the IaC pipeline or, where required, be performed manually once the deployment is complete. Because in IaC we are trying to do automation here, so I think as a final step we can do manual thing. It may be required in some scenarios, but let's go with the automation here. Insufficient hardening. Okay. The third element that commonly goes wrong in the IaC pipeline is insufficient handling. The primary goal of IaC is to rapidly deploy infrastructure. Then often means that the infrastructure that is being deployed has not yet been fully hardened. Hardening is not something that just happens automatically. It has to be planned for. As such, it is important to ensure that hardening steps are either embedded in the IaC pipeline or performed manually post-deployment. A common example of insufficient hardening is the services used by IaC pipeline for deployment. For example, when Vagrant does provisioning of a Windows host, it does this via WinRM connection. Okay. It just so happens that the WinRM is a service commonly used by threat actors for lateral movement. As such, it is important that if the service is no longer required for normal person operation post deployment, it should be disabled. When planning your IaC pipeline, it is important to include not only general hardening steps but also those that would close down the services used by the pipeline itself. Okay. Remote code execution as a feature. The last element to consider is to remember that ultimately IaC pipelines are nothing more than remote code execution as a feature. In essence, the pipeline is effectively executing code that allows for new infrastructure to be created and integrated into the existing networks. While this is incredibly powerful in right hands, it could also be extremely detrimental. Okay. Remote code execution as a feature. Oh yeah, so this is the holy grail of hacking, right? If you get remote code execution, you can do pretty much anything here. Taking this into consideration, it is important to apply security to the IaC pipelines to prevent unauthorized access. This can be done through two main security efforts, namely secret management. Yes, we highlighted that the secret management needs to be in place, and following the principle of least privilege. Okay. With secret management, we can ensure that sensitive information such as final credentials or keys is securely stored and cannot simply be read from the IaC source code to compromise the deployment. Following the principle of least privilege ensures that access to the IaC pipeline is only provided to the user and services that require it. This includes implementing the same security controls that should be in any pipeline as taught in the CI/CD and build security room. You can see that as well. If a threat actor can compromise the pipeline, they would often have the ability to also compromise the deployed infrastructure. These are some of the key security considerations that are required to secure your IaC pipeline against real-world threats. Now that you know what to look for, let's use this knowledge to attack a vulnerable IaC pipeline. I understand the potential security concerns with using IaC pipelines, and I am ready to put my knowledge to the test. Awesome. So guys, thank you for joining me on this room. Once we will come back, we'll start at task 7 and task 8 here. If you like this video, please give it a thumbs up, and if you haven't subscribed, please subscribe to the channel. Help us build the community, Desi community basically. Once you guys will come and try to put some comments in Desi Basha, so I will switch my language to either Hindi or Urdu, okay, or Punjabi if you like. So thank you guys, and I will see you in the next video. Bye bye.